So how do we sketch a polynomial? Several steps. Okay, a lot of this is actually review. A lot of it is exactly what we've just gone over. But basically, the word sketch means, what it means. It doesn't have to be exact. Sketch just means, make sure it's pretty close to the actual graph. Here's the first example. I want to sketch f of x equals x cubed minus 2x squared minus 3x. Okay? In other words, take that equation, figure some things out about it, put some points on a graph, and connect them with a curve. That's what sketch means. As far as a test or quiz goes, what you'll see actually is on the quiz, it'll be an equation, and then there will be 4 graphs to choose from. So you'll take the equation and you'll figure out which of these graphs goes with that. So it's a little bit easier since it's multiple choice, but at the same time, you still have to know how to get there. So the first thing you're going to do is find the x-intercepts, okay? Now, for this particular, for all examples actually, the first thing you should do is look to see if you can pull out a GCF. So in this case, you can pull an x out. You're left with x squared minus 2x minus 3. Now, I use the x method for this. You guys can use quadratic formula. You will get the same answer. In other words, a is 1, b is negative 2, c is negative 3. And then negative b plus or minus square root of b squared minus 4ac over 2a should get the same answer. If we use the x method, you'll have 1 times negative 3 goes on top, negative 2 goes on bottom. Then 2 numbers that multiply to give you negative 3 are 1 times negative 3, and add to give you negative 2. 1 plus negative 3 is negative 2. So then you take your original expression, your middle term, and break it down in terms of the 1 and the negative 3. So negative 2x becomes 1 plus 1x minus 3x. Then you pull out a GCF of the first two, which is x. You're left with x plus 1. The GCF of these two is negative 3. You're left with x plus 1. So notice when you do the x method, you get the same thing in both parentheses, x plus 1. That's your first factor. We still have this x that we pulled out originally. Your other factor is what's left over out of the parentheses, which is x minus 3, forms your other factor. But again, if you use the quadratic formula, you're still going to get the same answers. X equals 0, x equals negative 1, and x equals 3. But I'll go back so you guys can get that copied. So the next step is multiplicity of zeros. Can anybody explain why all these are odd? Why are all these zeros odd multiplicity? Right, good. They only appear once, which is an odd number. What does that tell us about what it's going to do on the graph? Well, I put a C here for cross. When you go to sketch the graph, it's going to go through the x-axis, okay? So I think we've done that enough to where we're pretty comfortable. If it's an even multiplicity, it will touch but not cross. The next step is the maximum number of x-intercepts. We're dealing with an x cubed function. Go back here for a second. There's the original, right? The biggest power is 3, so the maximum number of x-intercepts we can have is 3. Helps when you're sketching because that way you know it can't cross through 4 times, right? If you try to go through 4 times, that would be incorrect. Not the largest coefficient, largest power. Yes, largest power is 3. Coefficients don't matter for maximum number of x-intercepts. Who remembers how to find the y-intercept? Yes?
Plug in 0 for all the x's.
Yeah, exactly. So plug in 0 for all the x's. And the reason for that, I'm going to go to a graph real quick to explain this. Notice that, all right, here's the y-axis, okay? It can only touch when x equals 0, okay? If x is another number, you're not on the y-axis anymore. So that's why we plug in 0 for x. So we're going to plug in a 0 each time there's an x in the equation. So here's the original equation. We're going to plug in a 0. It doesn't matter, actually. But usually just go with the original. Plug in a 0 for every time there's an x. And so we get 0 this time, right? If every term has an x and you plug in 0, it's all going to turn to 0 anyways. So that means your y-intercept is 0, 0. Another shortcut, I think I remember somebody saying this. If you have an equation and let's say it had like a +1 at the end, that would actually tell you that's the y-intercept, right? Because every other term is going to turn to 0. So if you have a constant term, that's your y-intercept, right? And if it's all x's, then it's just 0. So that's a shortcut for that. But certainly we need to know where it touches the y-axis to make a good sketch of the graph. So this might be the only thing different than what you've already got filled in on your worksheet. Next step someone already alluded to, which is end behavior. We need to know what's going on the left and right. And because the leading coefficient is 1 in this case, and the highest power is odd, from that previous lesson, we know it's going to be going down on the left, up on the right. Okay? Next step is we're going to plot the information. So a couple things. The first thing you're going to do is plot your x-intercepts. So we found -1, 0, and 3. So you'll just put points there on the x-axis where you know it crosses. The next thing is the y-intercept, which in this case happens to also be the x-intercept. Normally it doesn't happen. So like if your y-intercept was 6, you'd put a point there at y equals 6. Another thing you want to do, which I don't have on here, like I told you guys, put your end behavior on the left and right. Since it's down on the left and up on the right, I know the graph is going to do something like that. Okay, and another thing you want to do is where you have those x-intercepts, either put a C or a T, okay? Now we already determined that it crosses at every single one of those, so you could put like a little C next to each of those points. That way you know when you connect it with a line. I'm going to erase this. I'm just going to do something random here. That way when I go through the points, I know that they'll cross through. They won't just touch. They'll go all the way through. Okay?
Why would it go up to
like I said, that was random. Oh. All right, so the only reason I did that was to show you that it crosses through. That's why I did that. All right, so that does lead us to the next thing. She asked, why does it go so high? Well, there's actually a way to tell how high it's going to go, or a pretty good way to know. And that is by plotting additional points. It's easy to figure out more points, so we can just plug in x values. Here's what I tell every single class, okay? You're going to first plug in a number to the left of one of these points, and you're going to pick the smallest. So what do you guys think that's going to be? To the left. -2, right? It's just to the left of -1. All right, then you're going to try to plug in a number in between 2 points. Now, -1 and 0, I'm not going to bother with because that's a fraction. I'm not going to plug in a fraction. But I can plug in a point between 0 and 3. So we'll do 1, okay? So we'll plug in a number here. And then the third point, you're going to plug in something to the right of your furthest right point. So 4, right? So any questions about additional points? Because when I finish this example, the 2 things I want you guys to do on the worksheet are to find the y-intercept, to plot the points. Sorry, 3 things. Find the y-intercept, plot the points that you have, and find the additional points, which usually is 3. Usually you have 1 on the left, 1 on the right, and 1 or 2 in between. So maybe 4. Like for example, if this if this x-intercept was over here, then I could choose a point in between. But since it's a fraction in between, I'm not going to do it. All right, so here's the 3 points that I chose. All right, so let's talk about this. You're plugging these into the original equation. So when we plug in that -2 point, which is furthest to the left, we're plugging it into the original equation, right? So it's -2 cubed minus 2 times -2 squared minus 3 times -2. okay? I'll talk a little bit about where this negative 10 comes from, right? What is negative 2 cubed? Negative 8, right? Well, if we simplify this, this is going to become minus 8. So it will be negative 16. Negative 8 minus 8, negative 16. But then we'll be adding 6 to that because it's minus minus. Well, what's negative 16 plus 6? Negative 10, okay? That means the first additional point is going to be negative 2. The first point that we're going to plot, additional point, is going to be negative 2, negative 10. So I'm going to end up putting a point up here, okay? Now you can see why that's helpful, right? Because that's, no, negative 10, sorry. It's going to be down here. You can see why that's helpful because it'll make the curve, you know, instead of like bringing the curve out here, I know it's basically going to be steep right there. Next additional number we plug in is 1, that point in between. So it's 1 cubed minus 2 minus 3 gives you negative 4 back. So that means the next point you plot is going to be down here, okay? So that's how you know how high and low it goes. Yes, exactly. Yes. What's your question? You got it? All right, and then the third point is the one to the right. Plug in 4. 4 cubed is 64 minus, what would that be? 32. So that's 32. Minus 12 is 20. When you get a point, so you know you're going to have 420. In other words, you know the point's going to be way up here. So when you go to connect the curve, you're basically going to be going straight up with it. So next step is to complete the graph. So we're going to plot these 3 points and then hopefully connect them with a curve that makes sense. All right, I'm going to show you the final product, but I'm going to explain how it got there. All right, so the first point you should plot is negative 2, negative 10, okay? And since this is off the graph, you can't really plot it, but you know it's going to be down here, right? So you know when you go to draw this graph, actually I did plot it, yeah, it's down here. When you can plot it, so you know that the graph is going to be going like this, right? Now if you'd gotten, say, negative 2, negative 1, then maybe it would go further that way. But we know it's going down on the left, right? Because that's end behavior. Next point we got was 1, negative 4. Now this is why it's called a sketch, because the graph could actually go further down than that, right? We don't know. So some people might go further down. It doesn't matter. It's just a sketch. And then the fourth point we got was 4, 20, which we can't plot. That just tells us that the graph is going to go way up there. Okay, so when you go to sketch this, maybe I can delete that and resketch it. Let's see what happens here. Yep. When you go to sketch this, you know it's going to go start down here. You're going to come up. Did that wrong. And then again, from right there, it doesn't really matter how high up you go. Just, you know, kind of be reasonable. Then we know it's going to touch that point, and then since it's going to go up on the right, and it's going to be 420, it's going to be steep. So we're just sketching. We don't know exactly what the graph looks like, but once we put all the information in, we know it's going to be pretty close to that. And not to forget to mention the fact that we knew it crossed through those x-intercepts, which is why we cross and not just touch. So any other questions about this? We'll go over another example tomorrow. What I want you guys to do today is just fill in the y-intercepts and the additional points on your worksheet.